In the mid-80s, American developers managed to revolutionize military aviation, opening up a new branch of development for fighter aircraft. It all began after conducting research on the combat effectiveness of fighter aircraft of the probable enemy. With the advent of the Soviet Su-27 and MiG-29, the U.S. lost any advantage to gain air supremacy. The decades-long Cold War and an overwhelming desire to be first in everything spurred the Americans to create a new generation fighter that would surpass the F-15 Eagle, already in service, and all existing fighters in the world. In the understanding of the Air Force, the fifth-generation fighter should have the following features: supersonic cruising flight speed without the use of afterburner, low visibility in a wide range of infrared radio frequencies, and also equipped with an advanced avionics complex. In 1983, the Advanced Tactical Fighter program starts, within which a tender was formed to develop a new generation fighter. 7 corporations entered the fight. The first stage was to design the appearance of the future tactical fighter. After a while, a specially created commission noted 2 clear contenders: Lockheed Martin and Northrop Grumman. This was predictable for the following reasons. Unlike competitors, Lockheed had hands-on experience with stealth technology, which was embodied in the F-117 Nighthawk tactical strike aircraft, and Northrop in turn created the B-2 Spirit heavy bomber. At the end of October 1986, contracts were signed with them, and work began on the creation of prototypes. In 1990, models were already ready for flight tests. Lockheed's designs were designated the YF-22A and Northrop's YF-23A. The prototypes were powered by the latest afterburner bypass jet engines. Completion of test flights in 1991 showed that Northrop's prototype, the YF-23, not only outperformed in terms of speed, but also had less radar visibility than its competitor, the YF-22. However, Lockheed's more advanced engine design proved to be more maneuverable, which was a major factor in banked combat against Soviet aircraft. It was decided to give the victory to YF-22. In the early 90s, the main enemy of the United States self-destructed, and the solution to one problem created another. The costly Advanced Tactical Fighter project, which cost taxpayers more than $66 billion, was no longer needed. The original plans to build 750 aircraft were clearly crossed out, and for 5 years, the state authorities were deciding whether the machine should be put into series production at all. Long negotiations by the U.S. Department of Defense and the Lockheed chairman with the U.S. Congress led to a positive conclusion. In 1997, a pre-production model, officially designated F-22 Raptor, took to the skies. Until 2000, the developers continued to bring the fighter to combat readiness, solving a lot of problems with the software. Also, at the request of the Air Force, expanded the range of combat lighting by adding air-to-surface weapons. In 2001, a contract was signed for the creation of 187 serial aircraft, which gradually entered the troops in several batches until 2011. The reduction in the state order by about 5 times raised the price to $150 million for one aircraft, thereby making the F-22 the most expensive aircraft in its class. Many people wonder why the Americans doubted the need to equip the Air Force with F-22 fighters and reduce the order to 187 aircraft. Raptor was created exclusively for air combat against Soviet fighters, while having a technological advantage. Currently, due to the lack of tasks, about 90% of the F-22 fleet is idle, gradually spending the military budget, as they require proper maintenance during the storage period. The export of Raptors is prohibited by U.S. law, although countries such as Israel, Japan, and Saudi Arabia have shown interest in this fighter. In 2014, for the first time, several F-22s were sent to Syria on a combat mission, the task of which was to conduct aerial reconnaissance and strike at ground targets. Although aircraft of the previous generation successfully cope with such missions. The history of the creation of the fifth-generation fighter in the socialist state began simultaneously with the launch of the American ATF program. Only the requirements for advanced aircraft were different. As mentioned earlier, initially the Americans needed an ideal fighter, and the Soviet government adhered to the principle of multifunctionality, since in the future the new project should replace all types of fighter aircraft of the previous generation. In 1986, by a decree of the Central Committee of the Communist Party of the Soviet Union and the Council of Ministers, the program for the development of a multifunctional fighter for frontline aviation, which received the designation I-90, was officially launched. With the coming to power of Mikhail Gorbachev in 1985, Promising military developments were rapidly losing funding. And later, they began to be finalized at all for their own budget of design bureaus, which significantly slowed down further work. But with the advent of the crisis in the early 90s, the first flight of the MiG-1.44 was delayed for 10 years. By that time, the Soviet experimental prototype no longer met the requirements of a modern fifth-generation fighter. In 2000, there was a kind of restart of the program, now referred to as I-21, also known as the Advanced Aviation Complex of Frontline Aviation. This time, in the competitive selection, preference was given to the Sukhoi Design Bureau, which in 2004 presented their fighter project under the T-50 index. The requirements of the terms of reference for the I-21 program reflected the capabilities of Western fighters, such as the Eurofighter Typhoon and the F-22 Raptor. According to the plan, the debut flight of the T-50 prototype was supposed to take place at the end of 2009, but in fact it happened in January 2010. And this is a very good indicator that everything more or less went according to schedule, a very rare thing for the Russian aviation industry. For 7 years, flight tests of 10 prototypes were carried out. The latest engines, avionics, electronic warfare systems were gradually added to each of which, and even the airframe design itself and composite materials were slightly changed. The last pre-production prototype of the T-50-11 took off on August 6, 2017 and received the official designation Su-57. Currently, mass production is already underway. So far, only a few copies of the Su-57 are ready. By 2028, the Russian Federation should receive 76 Su-57 fighters. The F-22 airframe has an integral layout and a special air intake design. The materials from which the aircraft is assembled are 40% titanium alloys and 25% composite materials. The remaining 35% is aluminum alloy. Most of the aircraft is sheathed with radio-absorbing materials and special paint, including the cockpit canopy, which is covered with gold plating. An interesting fact is that the aircraft model was designed on a specialized computer. The length of the fighter is 18.9 meters or 59 pounds. The height, taking into account the V-tail, is 5 meters or 16.5 pounds. The wingspan reaches 13.5 meters or 44 pounds. The mass of the F-22 without equipment is 19.7 tons. The layout of the Su-57 airframe is the same as on the American fighter. The triangular wing smoothly merges into the fuselage. The horizontal and vertical tail unit is all moving. The design of the aircraft turned out to be very successful, not only in terms of the capacity of the internal compartments for weapons, but also taking into account the reduction in the effective dispersion area. There is no exact information about the dimensions of the Su-57 yet. Data varies from source to source. The length of the aircraft is 20 meters or 65.5 pounds. Wingspan 14 meters or 46 pounds. The height is 4.7 meters or 15.5 pounds. The mass of the empty vehicle is about 18.2 tons. The F-22 is powered by 2 turbojet engines with an afterburner and variable vertical thrust vectoring. The engine develops a thrust of 15,900 kilograms in afterburner. Features of such a power plant are ease of maintenance and high maintainability. In the event of an engine shutdown during flight, onboard systems restarted automatically. The fighter has a top speed of 2,410 kilometers per hour or 1,498 miles per hour. In supersonic cruising, 1,960 kilometers per hour or 1,217 miles per hour. The maximum flight range, excluding external fuel tanks, is 2,300 kilometers or 1,429 miles. With 2 tanks, 5,700 kilometers or 3,541 miles. Testing of a new secret power plant for the Su-57, referred to as Product 30, is in full swing. This is a further development of the AL-41 F1 engine, which is temporarily installed in the first batches of the Su-57. Nevertheless, according to experts, the Product 30 will increase the main characteristics by about 5% compared to the current power plant. But one way or another, we will compare with what we have now. AL-41 F1 is a bypass turbojet engine with afterburner and thrust vector control, with a capacity of 15,000 kilograms in afterburner mode. The engine control system is electronic digital. It automatically regulates fuel injection, air supply, and ignition. In the event of a failure of all electronics, for example, due to the effects of a nuclear explosion, the engine running in reduced mode will allow the aircraft to return to base. The maximum speed is 2,440 km per hour or 1,516 miles per hour. Cruising 1,710 km per hour or 1,062 miles per hour. The flight range without external tanks is 3,440 km or 2,137 miles, and 5,500 km with external tanks or 3,410 miles. The combat load of the F-22 is 1,116 kg or 2,460 pounds of missile weapons, which, as befits stealth fighters, should be placed in the inner compartments of the fuselage. Also installed are 4 external suspension units, on which, in addition to attaching fuel tanks, they can be used to install missiles or bombs. But in this case, radar visibility increases significantly. Despite the fact that the F-22 is designed for air combat, modern combat realities increasingly require the fighter to play the role of a high-speed bomber. And this is quite feasible thanks to a set of special equipment, Joint Direct Attack Munition, which is attached to conventional bombs, thereby turning them into precision weapons with the ability to maneuver. In this way, any free-falling bombs up to 900 kilograms or 1984 pounds can be upgraded. And thanks to the ability to drop ammunition at an altitude of 15 kilometers or 9.5 miles at the supersonic speed of a fighter flight, the range increases to 50 kilometers or 31 miles. The combat load of the Su-57 is 1,310 kilograms or 2,888 pounds. 2 capacious cargo compartments, which are located in tandem inside the fuselage itself, accommodate the main armament of the fighter, as well as 2 additional small compartments. The combat load of the fighter can increase to 8,000 kilograms or 17,637 pounds. It's time to summarize. Researchers from the Institute for the Study of War recently released an article that described a battle scenario between F-22 and Su-57 fighters. The expected battle scenario will be as follows. The F-22 will be the first to detect the Su-57 at a long distance, while remaining invisible to the enemy due to the lower effective dispersion area, and accordingly launch missiles. The Su-57 may be able to maneuver and be able to evade the threat, but the chances are not so great. After that, the Russian fighter will receive a slight advantage due to the presence of an infrared search and tracking system. The most important parameter in the outcome of the battle will be the professional skills of the pilot and the capabilities of the airborne radar, the characteristics of which are unknown to anyone. A meeting between the F-22 and Su-57 is quite likely in the future. Both of these aircraft have excellent performance and are perfectly prepared for the future battle for the title of King of the Sky. Write in the comments which fighter you like the most. If you enjoyed this video, don't forget to press on the like button and subscribe to the Karo Show channel. Goodbye.